So our next subtopic is computer software. Computer software. So from our previous diagram, we noted that we subdivided the elements of computer into two, and we expounded on hardware part. So under this unit or this subtopic, we will expound more on software. So previously we stated that hardware are physical components of a computer system. Software are a set of instructions. Set of instructions that causes computer to perform a task. Causes to perform a task. So meaning that there are this part of computer that is not tangible, that is intangible components or tangible parts of the computer system. So then these softwares can further be classified into two. We have the system softwares, and the application softwares. So now classification, and the system softwares are softwares that manages system resources. We refer to them as system because they are installed to monitor and to make a system function as required. Like a computer system requires a system software, specific system software. So these softwares are hardware oriented. They are hardware oriented. That is, these are softwares that are made for hardwares. They are made to make hardwares work correctly. Systems here means a combination of parts, elements, devices that are working together. So these softwares make all these devices to work together to facilitate achieving of a specific objective. So they are hardware oriented. Then on the other side, application softwares are user oriented. They are softwares developed to be used by the user to perform a task. So meaning we'll further classify this more. We have further classification of these softwares. The system softwares will further divide them into two. We have the operating systems and the service programs. Operating systems, then service programs. We'll further subdivide this one again, but now we'll take operating system as a topic. Then we'll discuss more of classification. On the other side, application softwares, we'll classify them again into two. We will have the ready-made softwares. That is, sometimes we refer to them as off the shelf. And we have the other side, we have tailor-made softwares. These are softwares that are developed by a programmer. So give the programmer a certain situation and case, he develop a system for that specific case. So that is the simple classification of softwares. And now from there we'll start discussing now the specific softwares. We'll start with operating system. An operating system from the term operating, These are softwares, or they are specific software, very complex softwares that are normally created and installed in systems to facilitate operation of these systems. And some of the operation includes managing system resources like the CPU, memory, the input and output devices. So that is managing such resources. Another thing that this system do is managing logins and accounts. So meaning that operating systems are developed to facilitate systems works or to manage system, to facilitate systems to be operated by the liveware, that is the human, and facilitate security of this system, and again to manage all the resources installed in that system. So meaning you can define an operating system as a set of programs working together to ensure management of computer system. So this operating system is a compilation of a number of softwares that are brought together, complex program, and most important program that runs computer and controls computer operations. So it can be a bundled software that comprises of a group of softwares, or it can be one complex continuous program that is meant to manage system resources. So this operating system has specific functions. Why do we have to install an operating system in a machine? So from a small shell here, first we'll try to create the relationship between the user and the operating system. Then from there, we can derive the functions of an operating system. So for one to have a complete computer system, first we stated we must have the core, and the core here is the hardware. That is, you must first purchase the hardware part. Then after this hardware, you will have to install an operating system. An operating system may be Windows, it may be Android, or sometimes it may be Linux, Mac, and so on. Then after the operating system, you have to install now other application programs. And then user. You are the user. So the user will use this, or will use this application to control the hardware. So the user will type a document, for example, in a program like Microsoft Word, and then he uses this program to command the printer to print. But what normally makes this printer to print, there have to be an interface between the application and the hardware, and this is the operating system. So the functions of operating system, number one, is to start the computer. So after the initial self-testing, that is using the post through the BIOS, the operating system starts. The system starts the computer hardware. So starting the computer, that is the first function. Then another function is process management. Process management. That is function number 2, the process management. And when we talk of process management, we are referring to something of the sort. So during processing, we stated that 2 devices are used during processing. The first device is the RAM, that is the random access memory, and the other device is the CPU. And we stated that it's the work of the control unit to fetch instruction from the RAM, then take them to the CPU, then return the results back. So this is the processing pool, and the processing pool is controlled accurately by the operating system. So that is, at this state, when a program is here, we normally state that the program is in ready state. That is, this is a program that can run, or that is possible to run. It is in the ready state. So when you load a program in your machine, you start a program like an Excel worksheet, it loads here in the RAM. But so far you have not entered the data, you have not performed any calculation. So you have invited the program into the processing pool. So it is the work of the operating system to maintain that application in the memory. Then once you enter in the data and you want to perform a calculation, that is the time the control unit picks that data and takes to the CPU for processing. And here it will perform an arithmetic operation. So that is, it does schedule that task. So it is the work of operating system to schedule that task to the CPU. So you may have a number of tasks sent to the CPU. So these jobs are arranged here like a queue. Job 1, job 2, job 3, and so on. So it is the work of the operating system to know which job should go to the CPU first and which job should follow. And that queue proceeds that in those cycles. So it is the work of operating system to dispatch, to remove a task from here, then return it back here. So that is dispatching. So it's the work of operating system to control that process. And that is what we call process management. So it's the process, all programs running within the computer are managed by the operating system, including scheduling of tasks, dispatching of the tasks. So here, this is the running state. That is taking the task to the running state. And in case you want to remove that process out of the processing pool, then the task goes to the blocked state. So here, the program is not even loaded in the system memory. So that is process management. So another function of the operating system is memory management. Memory management, that is number 3, memory management. So when you are using a system, like you are using a mobile phone, sometimes you are using a computer, it is possible to tell part of the memory that is used and part of the memory that is not used. So why is it possible to tell this? Because our machine has an operating system. So the operating system always calculates. Anytime you are storing your information on the disk, it divides these disks radially into tracks and into sectors, such that it will be able to calculate whenever you store something, it is loaded somewhere on the disk until this sector is stored fully. Then it will proceed to the next sector and it can indicate the amount of sectors and tracks that have already been occupied by files. So it is the work of the operating system to allocate the limited memory space among many programs done using by the operating system, and again tracking the amount of space that is used and space that is not used. Then another function of operating system is input and output management. That is input stroke output management. So devices connected to a machine like this, like a computer or a laptop, anytime you connect a device, then the system always detects that a new hardware has been connected. So it is the work of the operating system to count and show the number of hardwares connected to your machine. So again, it can indicate those hardwares that are working and those that are not working properly. Hardware may not work properly, maybe because we don't have the supporting software, which you will see later, that apart from the operating system, you will require other supporting softwares to support devices. So the operating system detects the hardware, but the hardware has to come with its own software again, that is service programs. So then that is the work of the operating system to control any hardware connected to the machine. Then file management is another function of the operating system, file management. And in talk of file management, we are referring to creation of files. The operating system enables you to create files of different textures, maybe files of TXT files, that is text document files. It may be files of docs file, that is document files, or it may be spreadsheet files, XLS files, or database files, all these types of files. The operating system classifies these files by their extensions. So it allows you to create, to delete files, to rename files, and sometimes even transfer files, that is copy and transfer files from one location to another. So it is the work of the operating system to manage these files, to make sure that files are organized in the right manner. So that is file management. And the last function, okay, not the last, but the other function, number 6, is task management. So here, sometimes you may load several tasks in your system. You load a program, you load like 3 applications. At the same time, you copy file from one location to another. So the file is copying and 3 applications are running. So meaning that you have 4 tasks that are running in your system. So remember that operating system, the CPU can only process 1 task at a time. But the operating system will enable you load the 3 tasks at the same time. So what the operating system will do is it will subdivide that CPU time into 4 slices. And you will see like the 3 tasks are running at the same time, but the CPU will be processing 1 at a time and interchanging. So that is another work of the operating system to manage these tasks. And in case you want to stop some tasks, then you can use the task manager to do so. So allocating processor time among various programs and oversees these tasks, duration and such. So that is another function of operating system. Then the other function, number 7, is error reporting. Operating system does report errors. Some simple errors, for example, maybe you open an application, you want to type a document, and you try to close the document without saving. Then an error will appear on the screen that trying to close the document, have not saved the document. Such errors, in case we have a hardware that is not running properly, then the system will still indicate an error. Maybe the printer has an error, so the operating system will always give you such errors to indicate when a hardware or a software is not working properly, or when the human or the person operating the system performs an illegal operation. So all these errors, both hardware, software, and operation, that is tasks done by the user, human errors, are reported by the operating system. Then we have event logging, another function, that is event logging. So whenever you open up your system and you start loading different applications or activities happening in that particular system, maybe the computer, the mobile phone, a server, or you are running in a network, are recorded by the operating system. It is possible to tell all the events running in that particular machine. So the operating system has those event logging facilities that shows the number of application or tasks that have been logged in. So all activities performed by the computer are recorded by the operating system through event logging. So those are the major functions of operating systems. So the next part is classification of operating systems. Classification of operating systems. So operating systems can be classified according to three criteria. Either, number one, according to the purpose of that operating system, the number of users they can support, or the number of tasks they can support. So you have three classifications. That is, the first one is according to purpose. Then we have number of users, the number of users they can support, and the number of tasks they can support. So starting with the purpose, according to purpose, we have two main classification of operating system according to purpose. That is, we have dedicated purpose operating systems, dedicated purpose operating system. We have general purpose operating system, general purpose operating systems. And these are the two main classification according to purpose. So in talk of operating system that is dedicated to perform a specific task, that is a specific purpose, this one normally depends on the hardware or system that is being used. Some systems, especially those systems that are specific, they have a specific purpose. Like some machines, some of these machines used in medical field, like in scanning. Those machines used to scan, or even some devices. Like we have specific devices used, like the personal digital assistants used by like the Kenya Power people. Those small machines they use to read the bills and so on. We cannot call them laptops because they don't have a general purpose operating system. You cannot use them to type a document and to do such. They are specifically used for that, designed for a specific purpose. They have an operating system. An ATM, for example, have an operating system. But you cannot go using an ATM machine to type a document. So it has a dedicated purpose operating system that is specifically used for that reason. So they are permanently installed in the ROM. So these are installed in the read-only memory. And they are installed, they are permanent and by the manufacturer. And they are normally used to do a specific task to control those specific devices. So such machines like elevators, you have the petroleum pump, automatic door systems. They have specific operating systems that are dedicated for their own functions. So we call them dedicated or special purpose operating systems. Then we have the general purpose. The general purpose operating systems are the ones that we normally use in our machines, in our mobile phones. These are operating systems that can be customized. They can support various processes. So meaning that you may have a machine and use this machine to do a number of tasks. Because the operating system that is running there can allow you install different applications. So then we call these operating system general purpose operating system, like Windows, like Mac, Linux operating system and such. They fall under this category of general purpose operating system. And according to number of users, so operating system can be classified as single user or multi-user. So operating system that is single user, it means operating system that support only one user at a time. So that is single user operating system. We have others that can support several users at the same time. That is multi-user operating system. So whenever we talk of operating system being single user, then the element of networks again comes in. An operating system that is single user cannot support network. So this one not support network. So it cannot allow two devices to be connected together, because once you connect to a network, then automatically the element of multi-user comes in. So these are operating systems that support one user, so they can allow only one user to log in, either at different times or at one given time. So that is that is single user operating system. And examples, we have the older Windows, like those Windows like Windows 98 and Windows, those older Windows that used to operate in machines. They are single user. They could not support networks. So such we could refer to them as single user operating system. Then multi-user, these operating systems are designed to support more than one user at a time. So they can support networks. So you can establish a network and two people may be logging into the same system at the same time. So they support networks. And again, they can allow different users to log into the system either at different times or at the same time. So like in time sharing, where we have just one machine and with several monitors, and every dump station is working, is doing its own operation. We have one dump station here, another dump station here, and all these machines, every machine is doing its own operation, but one CPU, meaning that this CPU must have a multi-user operating system. So that is examples. We have now the modern Windows operating system like Windows Server. Windows Server is a good example of multi-user operating system. Other Windows Server, we have such Windows. We also have Linux that support server, and we have the Mac operating system. So any Windows that runs in a server is a multi-user operating system. So according to the number of tasks, then we can say we have single tasks. We have operating system that support only one task at a time. That is, cannot allow two tasks to happen at the same time, like the disk operating system. So is a good example of operating system that can only support one task running at one given time. Then other operating systems like Unix still uses single tasks method, and most of these operating systems are command driven. They are command driven. That is, you operate using commands. Then we have multitasking. These are operating systems that do support several tasks at the same time. So the operating systems can allow the user load like several programs at the same time. And a good example we have again the modern Windows, like Windows 10, Windows 7, 8 and so on. All these Windows can do multitasking. So they are designed to support many applications at the same time. So that is the classification of operating systems. So the other part of system software, we stated that system softwares can be classified into two. That is operating system and service programs. So service programs. So service programs are designed for general support of the processes of a computer. So these are softwares that are designed. They are also system softwares because they support hardware, but they do general support of these hardwares and other services. And the reason why we call them service support, because services that runs in a system need to be supported by specific softwares. So let's say, like for example, a service like data recovery is a service itself. So you are recovering data from a hardware. So you must have a recovery application. A service like restricting unauthorized access to the database, you require a firewall. Firewall here is a service application. So this service program can be divided into three. So you have three classifications here. So number one, we have utilities or utility softwares. The utilities are the most common service programs that we use. Then other service programs, we have communication softwares. So the protocols normally used in networks. And number three, we have development programs. Development programs. That is, they support development process of other applications. That is communicating to the CPU, converting human language to machine language. So starting with the utilities. So and these utility softwares perform various tasks that maintain and enhances computer operating system. So some of these utility softwares are like antivirus, the antivirus program. We cannot say that antivirus is an application software because we don't apply it to do a task like to type a document. So the reason why we must have an antivirus is to support our machine and protect our machine from the damage caused by the viruses. So it actually adds more function to the operating system. The operating system may have a way of maybe restricting virus, but sometimes not that diverse, because viruses keep on changing. So you need an antivirus application, that is an antivirus utility. Then another utility program is data recovery utility, and these are normally used whenever you lose your data, either through accidental deletion or sometimes maybe the failure of the hard disk. So these data recovery utilities attempt to restore data and files that has been damaged either accidentally or sometimes by failure of hardware. Then we have the firewall, and firewall is a utility that is embedded again on operating system to prevent outsiders from accessing your computer over a network, such as internet or other networks connected to your machine. So that is the main utility application that are used, but we can still add others like data compression utilities. So we have disk compressor. The disk compressor, these are softwares that allows you to compress the files, either to occupy a small space, or sometimes when you want to send these files over the internet, you need to compress them. So other utilities may be disk defragmenter, and a disk defragmenter tries to bring files that are separated different location of the disk to one location, so that the disk or the system can read these files faster. So that is, it allows that faster or improves the speed of reading the files. That is disk defragmenter. So those are some of the utilities application that need to be added on the operating system. So the three parties, we have developers, CPU, and translators. So the translator translates the human, because this is the human, the programmer is a human, to translate the human language into machine language. This is a machine. So meaning that within the machine, you must have those installed systems, either on their own, that tries to translate whatever the developers type into the CPU language. So that is the development softwares, and they start from, first we have the text editors, where the programmer writes in the code. So the text editor is the first text editor. Is the first development application. So the programmer will have to use a specific software to type in the code. That is in the form of more of text document files, like Notepad. You may use such programs to type in the code. Then from there, once he types in the code, then he uses the same editor to run the code. So that is the first development application. Then apart from this, then within the CPU, we will have assemblers, and these assemblers allows code to be translated from the assembly language, that is the language of symbols, into machine readable form. If the developer is using the language of symbols, that is what we call the assembly language, then it requires an assembler to convert from human language to machine readable form. Then another development program is interpreter. And interpreter, again, just like an assembler, will try to or will convert the human language into machine readable form. But now here it will translate line by line. That is line by line. So the programmer types one line, then it interprets. Then types another line to proceed interpreting line by line. That is interpreter. Then the last one is compiler. And the compiler now awaits the programmer to type the entire source code. So you type the entire source code, and then it translates at once from the human language to machine readable form. So it compiles the entire source code and then translate it at once to machine readable form. So those are the three development applications that are needed by the programmer. So then the last part is communication software, and this refers to program that makes it possible to transmit data. Apart from the operating system operation has added the softwares in it that allows transmission of data from one machine to the other. So these programs, we refer to them as protocols. So that is, we have added the softwares in operating systems that facilitate transmission of data. Like we have file transfer protocol that is used to transfer files from one machine to another, maybe connected through a direct cable. We also have others that facilitate transmission of data over the internet, like the simple mail transmission protocol. We have the transmission control protocol and the hypertext transfer protocol. So these are specific softwares that have to be embedded in operating system to facilitate transmission of data. And this that marks the end of the service programs. So the other part, or the other classification, we need to expound further. Remember that we started by classifying softwares into two. We stated that we have the system softwares and application softwares. And whatever we have discussed so far, system software. So that is the operating systems and utility applications. So you need to expound further on application softwares. And we stated there earlier that these are user-oriented. They are softwares that are created for the user. So when the user wants to perform a task, for example, the user wants to type a document, want to design a graphic, the user may want to edit or do statistical financial statements, draw something, he have to open a specific application. So, and these are the programs we call application softwares. So the application softwares can further be classified into two, and the first classification is general. The general softwares, that is general softwares, general purpose softwares. And the reason why we call them general purpose, because these softwares are created to they can perform several tasks depending on the area that they are being applied for. So we can call them general purpose, or sometimes we can also refer to them as ready-made, because to get these softwares you go and buy them from the shop, from a vendor. Or sometimes you can also refer to them as off the shelf. So these softwares, you buy them from a third-party vendor. So, and the other classification we stated is tailor-made. And this is a situation where you have tried to use the general softwares and found that you don't actually achieve the specific purpose or the specific task that you want to achieve. So you have tried to use a spreadsheet like an Excel worksheet to perform an accounting operation, but you find it is not possible to do so. Or maybe in a supermarket they have tried to use a program like Access to perform their tasks, but it's not possible to do so. So they will have to call a programmer, and the programmer will develop their own application, that is tailor-made the application according to the functions of that specific business. So the general ready-made softwares are normally developed to perform variety of tasks. So that is the developer of these softwares, like for example, like Microsoft, they will sit down and analyze the operation of most businesses worldwide. Then they will create an application that you try to capture, or that you try to capture most of the tasks done in an office case. So, and they can produce a bundled software. That is, they produce a software that has several softwares inside it. Like we talk of Microsoft Office, this is a software that is bundled. It has a number of software within it. So in an office case, you may want to type a document, then you can have a program to type. You may want to perform some calculations. You may want to present your work. Then you can have like a PowerPoint program. And the entire of this comes with a number of softwares that can handle an office case, a bundled software. So, and some of these general or ready-made softwares includes word processing applications. So you can just highlight and give some examples. We have word processing application here. We can use Microsoft Word. We have spreadsheet programs, and spreadsheet programs are normally used to enter in data and perform basics calculation. So here we can have a program like Excel. We have database management system. Database management systems, these are applications that allows you to analyze, formulate, and manipulate data in a systematic way, that is using a database software. Like we may have a program like Access, and other softwares like using presentation softwares like PowerPoint. We have desktop publishing softwares, desktop publishing softwares. So these are normally used under the umbrella of computer artwork, that is framework of art and design, to create graphic design and publications. So here you may have softwares like Publisher, like CorelDRAW, like Photoshop, Illustrator. All those programs used in graphic design are normally ranked under desktop publishing softwares. We also have other softwares that are normally use multimedia, and here we have several multimedia applications. We have softwares we use to run and to play videos, programs that are used for editing, animations. So all these animations, we have video editing softwares like Adobe Premiere. Here we have 3D Max. We have other applications used in just to play the videos like the VLC and Microsoft Media Players and such. All these applications are under multimedia, and all these applications you can refer to them as general or ready-made softwares. So then on the other side we have the tailor-made softwares. The tailor-made softwares, we stated that they are made or they are developed by in-house developers, or sometimes outside or outsiders, outsourcing. So a company can outsource the software from other people, but still the software had been developed according to maybe a specific requirement. So, and these softwares, we can give examples, like we have the billing systems, most billing systems. We have payroll systems. We have the electronic point of sale systems, the POS used in supermarkets and such, and all those systems that works in certain cases, then we refer to them as tailor-made application. So that is that one marks the end of the application softwares. So let's check on a question from May 2015. Question 2. Question 2C. Question 2C. Outline 6 benefits of a closed software. Outline 6 benefits of a closed software. That is, we said May 2015. Question 2C, Roman 1. Outline 6 benefits of a closed software. So meaning that we have closed softwares and we have open softwares. So why do we call a software closed? Closed. And what can we, or maybe which softwares can we connect with these closed softwares? So we normally term software being closed because the programmer have finished developing the software, and once he finished developing the software, he compiled the software such that the user will not see the back-end codes. The user cannot access the coding behind the software. So when you are using a program like Excel, you will not see the back-end software, the back-end coding. So meaning that the software has already been closed. So meaning these closed softwares, most of them are ready-made. They are ready-made. And most ready-made softwares, actually all ready-made softwares are closed softwares because they have been developed, and the programmer, once he developed these softwares, he compiled them such that the user will not get the source code. So benefits of this closed software, it means you give the benefits of ready-made softwares. So, and by doing so, you'll be able to get the benefits of ready-made softwares. So that is question 2015. So let's check. So ready-made softwares has a number of benefits, and some of these benefits we are told here to outline. So we are not just expounding more, we just outline the benefits. You give or you outline. So benefit number 1 is easy to implement. Easy to implement. That is, install and start using. So when you buy a closed software, you don't have to check the server, you don't have to check the database, where the database will be going and so on. You just install, copy it to your disk and install. So the software has already been created, formed, where it will be backing up the data, location where it will save by default and such. Settings, maybe you just change a few settings, but it is very easy to implement other than using an open source software. Then another benefit, can meet a variety of users' needs. Meets variety of users' needs. So it can meet a variety of users' needs. So meaning that most of these closed softwares, because they have been tested by so many companies and they have been tested by several parties, they can be applied in a number of areas. Like most ready-made softwares, say like, for example, you can use a spreadsheet to do variety of tasks, either to manage a shop, to manage to keep record of students, to keep records of maybe residential tenants and so on. So it can be applied in variety or in different areas. Then cost effective. They are cost effective. And cost effective here, I mean comparing the cost or the closed softwares with other softwares, like what we talked of, the open source, the tailor-made softwares. The cost of this software has been distributed among different users. So meaning that the party or the developer will create the software not for a specific person. He create this software and then create several copies. So, meaning that by doing so, the cost of that software will have to go down because you have to distribute cost to several people, other than when you call a programmer to develop a software for your specific case. So, these softwares are well documented. They are well documented. So, both for technical staffs and for users, the softwares are documented. They normally comes with a manual, so you can follow the user to know how to use the application, or sometimes the technical staffs to install and to support. Then the other one is these softwares are thoroughly tested. They are error-free, because they have been tested and employed in various companies, and every time this software is deployed in a company, the feedback they get from these specific companies will always help them to advance on that specific software. So those are some of the benefits of using a closed software. We state that closed softwares are closely linked, or they are linked with the ready-made softwares. So, meaning that if you have closed software, then you have open softwares. And open software here we are referring to open source softwares. An open source software is a software that has been presented with its own the back end, that is open source. And open source simply will mean that this software can be modified by the programmer. You are presented with the coding. An open source software, you can actually see the coding. And these softwares, we can link them with tailor-made softwares. Tailor-made, because the tailor-made software is a software that you can always modify. So they can be modified, and the benefit of using these softwares are the benefit of using tailor-made software. In this case, you are told to give benefits of closed softwares. Then Roman 2, that was Roman 1, Roman 2, you are given, citing 2 examples, highlight 4 benefits of bundled software. Benefits of bundled software. So what are bundled softwares? So when you talk of bundled software, we are referring to software that is created as a set, a suite of programs. So, and if like can give an example, e.g. like Microsoft Office is a good example of bundled software because it comes with a number of applications. Other softwares we have like Adobe, the Adobe suite that comes with a number of softwares again. We have other softwares created by Autodesk. We have the Autodesk suite. The Autodesk suite normally created the softwares we call the computer-aided design softwares and animation softwares. We have the GraphSoft, GraphSoft. Again, they also create the programs used for architectural design and interior designs. So this software comes as a suite. And coming as a suite, it means like if it is Adobe, once you install this software, you get software for graphic design, for video editing, for After Effects, and for photo editing and so on. So in this case, we are told to give examples and benefits of using these bundled softwares. So examples we have already stated. We have seen these examples: Microsoft Office, For example, we have Adobe Suite, the Autodesk, and so on. But the benefits of these softwares, it reduces cost of acquiring single softwares. That is the first benefit. So reduces cost of acquiring single softwares. Like you have programs that are created as a single software. For example, a program like QuickBooks is a software that has been created as just one single software. So meaning that you don't have a suite for this, but you have a suite for this. So when you are buying this software, it's a bit costly to buy this than to buy this. Because here you buy one, but you get several. So it reduces the cost. Then again, occupy less storage space because the software are integrated. So these software installed as suite are integrated. So you run only one setup, but you install all of them. So that integration makes the software to occupy a lesser space as compared if you had to purchase single software on that particular suite. So then are easy to, so we stated that it occupies less space. Then the other benefit is that easy to install because it's already packaged. It is easy to install. Because the software is already packaged with only one setup. If it is Microsoft Office, you just run one setup and you get all these softwares again installed in your machine. So they are integrated, and that integration normally brings the concept or allows the user to bring the concept of one application to the other. So meaning that you can switch from one application, you can switch from Photoshop then to Illustrator because the software has been integrated together and it becomes easier to use these softwares. Then they are easy to maintain. So that is the benefits of using the bundled softwares. Question, that is what you are supposed to give. Again, we stated that when you're giving these answers, you need to check the number of marks given per every question. You're supposed to, if it is 4 marks, you're supposed to give at least 4 points. So our next subtopic, we'll discuss about programming languages. So, and what is a programming language? First, we have been using languages like the languages we use, English, French, and so on. These are languages that allows users or humans to communicate with themselves. Now, we have languages that allows humans to communicate with machines. And this set or these artificial languages that can be used to control the behavior of a machine, particularly computers, are the one we call programming languages. So meaning that a programming language refers to a set of words, symbols, or codes that are used to prepare or develop a computer application, a computer program. So the programming languages are used to facilitate communication about the tasks for organizing and manipulating information. So, and we can classify these programming languages again according to the levels, how the program or the language is near to human language or how the program is near to machine language. So, if here we have human here, and here we have a machine. So machine will just have a CPU. We use this sign to show the CPU. So if that is our CPU, is the machine. And here we have the human. So the languages can be classified into that. That is, we have languages that are close to human language and those that are close to machine language. So machine only understands the binary codes. Binary codes, that is the binary digits, zeros and ones. But here, human language is an expression that can be controlled using characters and symbols, gestures and all these. So meaning that the major classification of programming language, we have high-level languages, that is, these we call them high-level languages because these are languages they are languages close to human language. Then we have low-level languages. Low-level languages. We refer to them as low-level because these languages are close to machine language, or they are already in machine language. So the programmer will use his own high-level language, but to program, they have to be converted to machine language. And what converts the high-level language to machine language, we refer to them as language translators. Language translators. And these language translators, we stated them under the softwares. We stated that we have interpreters, we have compilers, and we have assemblers. So these are the interpreters that interprets the human language to machine language. So we'll start first with the low-level languages. And low-level languages, we can subdivide these low-level languages into two. The first language is machine language. The machine language, that is the language that the machine understands, is the low-level language. And this is the language of zeros and ones. Zeros and ones. These zeros and ones, we refer to them as the binary codes or the binary logics. So the language is usually expressed in these digits, and every compilation of digits, like we have 8 of them, the 8 compilation of 8 digits, we refer to them as bits, then represents a byte. 1 byte, and from that byte then you can have some character or information being represented in a machine. So every character that is starting from A up to Z and 0 up to 9 have its own binary equivalent. So meaning that every character like letter A has its own binary equivalent of 8 digits, zeros and ones. Up to Z, again, 0 up to 9 have its own binary equivalent. So that is the machine language. And when you want to code using the machine language, then you have to understand this binary equivalent of every character. So the language is a bit difficult to learn and understand, and sometimes it takes too long to develop even a simple application. The other language is assembly language. The assembly language was established to make it easier to program. And this is the language of symbols, that is special characters. So from the word symbol, then we get the assembly language. So, and this language, machine language, need not to be translated because it's already in machine readable form. It will not require the language translators. But the assembly language requires an assembler to translate it to machine readable form. So that is, we require an assembler to translate to machine readable form. So these two languages, we need to check on the advantages and disadvantages of these languages. That is, advantages of low-level languages. So the advantages of these languages, one, we say that the language or these languages are a bit difficult to analyze. So advantages. So the first advantage of using low-level language, the first and the main advantage of using the low-level language is that the languages are stable. That is, programs written using these languages are stable. Since they are already written in machine readable form, they hardly crash. That is, these softwares are read by the CPU as they were coded. Again, another advantage, they do not require translation. So, no translation required. So, the program is coded and immediately the CPU can read this program as it is coded. Then, number 3, these languages runs faster. That is, they are executed very fast. Executed faster, because the CPU requires no translation to translate the language into machine readable form. Then the program runs faster as compared to the other languages you discuss later. So, and we stated that they are machine independent. They are machine dependent. That is number 4. That is, they are created for a specific machine. So you don't create them to transfer them to another machine. So they are only developed for a specific machine. So that can be a disadvantage to this. Disadvantage. That is, they are machine dependent. Machine dependent. And being machine dependent means that you cannot transfer that application created using the machine language from one machine to another. So these softwares are not portable. Simply, the softwares created in machine languages are not portable. So you cannot transfer the software from one machine to another. So that is the advantages and the disadvantages of the machine language. So both the assembly language and the machine language will share the same advantages and the same disadvantages. Then on the other side, we can add more. It has more disadvantage. More disadvantages we can add here. Number 2, that these languages are difficult to use and difficult to use, and to program using these languages a bit quite difficult. Learn and understand the language. Then again, difficult to debug. It's also difficult to debug. That is, to test, to debug and remove errors. In case an error occurs during the program development, then it becomes a bit hard to debug or to remove these errors. So those are some of disadvantages of these low-level languages. High-level languages, on the other side, these are languages that are close to human language. That is, the human language is the language like English-like language. So these languages, we refer to them as human language because they normally use the human language syntax, words, short words, that are English-like. And human, even those people who are not programmers, once they get these codes, they can actually have clue or understand that is what is going on. So the language that are very close to human language hence easy to understand and use, allows problems to be solved using the human or specific, using the human language on human-oriented manner. So these languages are further classified into other 5 generations, because in this machine language can be termed as first generation language. Then this is second generation, the second generation language. So from here, then we have the human language starting from third generation. And third generation languages are also referred to as the structured programming languages, or procedural programming languages, or modular programming languages. So these are languages that create or facilitate creation of a program through developing a program using modules. You get modules, you bring them together. That is third generation languages, modular programming languages. And some examples of these languages, we have some examples, like we have basic, beginner, all-purpose symbolic instruction code. That is the basic. We have common business oriented language. Common business oriented language. We have the formula translators. We have C, languages like C, that is C. And such languages can be termed as structured programming languages, that is under the third generation language. Then fourth generation languages, sometimes we refer to them as the Visio programming languages. The reason why we call them Visio programming languages, because they make programming even more easier by presenting to the programmer tools that he can use to create the program very fast and with no errors. So it presents to the programmer things like forms, other things like buttons. The programmer will not have to type codes until the button appears. Instead, he can pick the button and press it on the form, text boxes, text fields, and so on. So it makes the program more easier to generate. That is fourth generation languages. And they are visualized. These are languages that are visualized. So the programmer will not concentrate much on typing the codes, but developing the application. So, and examples of these languages, we have these visualized, third generation visualized, like we have the Visio Basic, we have the Visio COBOL. Here we have a program known as Pascal, and here we have Delphi, Pascal. So these are the Visio programming languages, and the languages have that Visio appearance where the user can interact or create the application without having to type so many codes. Then after the fourth generation, we have the fifth generation languages, and these languages are normally created for artificial intelligence. That is, they are created to create programs. Instead of programmer having to type the code, then the programmer only concentrates on the problem. Then the system develops a program automatically without any coding. So these are artificial content management systems. Like most content management systems, that is CMS, are examples of the 5th generation languages, because they work under the principle of code generating themselves. So like we have systems like the use of the WordPress, normally used in web development, and Joomla applications, that once you just place a button or you create a program and it generates the program for you. Others that are more even sophisticated, like the Lisp, we have the Mercury, are applications still used to develop codes automatically. Then after the 5th generation languages, we have object-oriented programming languages. So we call them the OOPs. And these are languages that works or create the program through the concept of objects. An object here is an entity, is different from a module, because this is an entity that can exist on its own. It can exist on its own and can be integrated by another object to create or to form a better program. So the object-oriented approach is one of the modern approach of developing applications, where you just create an application and this application can be integrated with another program. So like we can integrate, like M-Pesa, for example, is an application that can be integrated with anything else that need to transfer funds from one location to another. So it's through the object approach. So, and here we have languages like Java, we have the C++, we have programs like Python, and such languages, high-end languages that are used to develop system through the object-oriented approach. Then the last part of programming language, we call them web scripting languages, high-level language, web scripting languages. And these are languages that create application that runs on the web. So web scripting languages. And some of these languages includes, we have the normal HTML language, that is the hypertext markup language. We have JavaScript. Java is an object-oriented language, but we have JavaScript, which is a web scripting language. We have the PHP language, that is the hypertext preprocessor, which is always connected by MySQL. A language too, SQL is a language, so it has to be linked together with MySQL. And other languages like the CSS used for styling websites. All these languages are deployed to develop web applications, that is anything that runs in the web. So, and that terms the high-level language, and the reason why we call them high-level language, because they are high, they are near to human language, and they can be used to produce even complex applications that can be applied for the day-to-day operation of a business. So the next thing, we're going to check the advantages of these high-level languages. And from whatever we have seen, is that high-level languages are easy to learn. They are easy to learn and use. easy to learn. Advantages. They are easy to learn and use. Because they are near to human language, you don't have to strain too much on the binary equivalent of every character. So you just need to know your language, again, you know the operation, the problem that need to be solved. Then another advantage is that the programs written in these languages are portable. Programs written in these languages are portable. That is, they can be developed by one machine and installed in another machine. So meaning that we call this one that these programs are portable. They are machine independent. So they don't depend much on the machine from where they were constructed from. Then the disadvantages of these languages is that they are less effective. They are less effective when it comes to processing, execution by the CPU, that it takes longer for the CPU to process these languages. So, take long to process or to execute, because the CPU will have to first to translate them into machine readable form before it executes them. So that is the main disadvantage of this machine readable or the machine readable form. So the program takes long to load, to process, to be executed by the CPU. So, and that marks the end of these programming languages. So let's look at question from the paper, May 2019. Question 2. May 2019. Question 2A. The question states, describe 4 distinguishing features between low-level and high-level programming languages. Question is given 8 marks. So we are supposed to distinguish between low-level and high-level languages. So from our previous topic, we stated that low-level languages are referred to as low-level because they are close to machine language, and high-level because they are close to human language. So to distinguish these two levels of programming languages, then the simplest way is to use that tree format, table format. So we can draw a small table like this, and then we will distinguish by stating one characteristics of one and characteristics of the other. So like the first, low level, they are faster than high level languages. Low level, faster in execution. They are faster than high level languages. High level languages are comparatively slower. That is in terms of what? The CPU takes less time to process a low level program created in low level programming languages than the time it will take. This one takes it takes more time to process a program generated in high level language. So another characteristic is that low level languages are memory efficient. That is, they take less memory. A program created in low level languages takes up a smaller space than compared to a program created in high level. High level languages are not memory efficient. A program here takes more space, more memory compared to a program generated in low-level languages. Another characteristics is that low-level languages are difficult to learn. They are difficult to learn and understand, a bit difficult to learn, and the reason behind this is the program you need to understand and to cram all the binary equivalents of characters. That is from A to Z, from 0 to 9. You have to know all the binary representation of numbers, which is a bit tough. So, and then from there, you can now concentrate on now developing a program where every character is represented with by a group of 8 bits. So it is difficult to learn and understand. But high-level languages, because they are close to human language, these languages are easy to learn and use. Easy to learn and use. Easy to learn and use. So another feature is that programming in low level requires additional knowledge of computer architecture. So to program in this low level, you require more knowledge of the design of the CPU, because the program is developed for a specific device, for a specific CPU. So first, before you program, you have to understand the specific device, the design or the architecture of the device to which you are programming to. As compared to the high-level language, you don't have to learn the device, because the program can be written and used in another device. So programming in high level do not require any additional knowledge of the computer architecture. So no knowledge of the CPU design. So you don't have to learn more about the architecture of that specific hardware to which you are programming for. Then another distinguishing characteristic is that that is number 5. Number 5 can say the low-level languages. They are machine dependent and not portable. They are machine dependent. Being machine dependent, we stated that the program created for one machine cannot be transferred and used in another machine. So meaning that the program is only developed for a specific device, not portable. But high-level languages are machine independent. They are machine independent, and being machine independent, it means that a program is portable. Here we say that not portable. Not portable. Here portable. So a program can be created for one device, then copied and installed in another device. So it is portable here. Then another characteristics, number 6. Remember, we are given 8 marks, so you need to have at least 8. So they are more error prone. These are low-level languages are more error prone. That is, they are more prone to errors. More prone to errors. So the reason why they are a bit prone to errors, because of difficult to learn. These languages are a bit difficult to use, again, meaning that the programmer may end up having so many errors. As compared to high-level languages, and here we say they are less prone to errors. Less prone to errors. So here they are less prone to errors. because here the programmer uses a language that is close to his normal language, English-like language. Hence, he can really cause very few errors as compared to low-level languages. Then another feature, number 7, can say that debugging and maintenance in low level is difficult. So that is 7. You can say difficult to debug. Difficult to debug. To debug is to do what? To debug is to check and correct errors. So a bug in programming simply means error. An error, which we call the syntax error, that is error that has been caused by the wrong use of the programming rules. The wrong use of programming rules. So such errors, to correct them, such errors, we say you are debugging. So here it's difficult to debug. Low-level languages, it's difficult to debug. But high-level languages, debugging and maintenance is easier, is comparatively easier. So here you have easy to debug, So that is, we have debugging utilities that comes by high-level languages, where the user will not have even to go checking codes one line after the other, but the user can just use a debugging or the software to debug and to check errors. So, and it always display errors without having to take too much time. Then the last one, number 8, we can say the low-level languages, high-level languages. We start with low-level language, number 8. And here we can say that they are generally used for developing system softwares. That is number 8. Low-level languages are normally used to develop system softwares. And system softwares like what? Like operating systems normally used to control machines, hardwares embedded in hardwares, in chips, on motherboards and such. So system softwares. But high-level languages are normally used to develop application softwares. They are normally used to develop application softwares. So application softwares are softwares that are used by the user to perform specific tasks. So sometimes you can refer to them as desktop application. Others, websites, mobile softwares, etc. So those are the two distinguishing characteristics of high-level languages and low-level languages. 8 marks. Roman 2, that was Roman 1. 2 examples of high-level languages. 2 examples of high-level languages. So that is, let's just move this. So we stated examples of each, from low-level languages to high-level languages. And Roman B, we are being asked to give now examples. And we are given 2 marks. So I mean, you can just give 2 examples. You can give more, but in an exam case, just 2 are enough. So we are not specifically stated under which level under which level should we give examples. High-level languages are so many languages, as we have like 3rd generation, 4th generation, 5th generation, object-oriented programming, web scripting. All these, we stated some examples. So 3rd generation, here we stated like we have languages that we refer to as structured programming languages or modular programming languages. Like we have Pascal, we have C, we have COBOL, Common Business Oriented Language, we have BASIC, and so on. So some languages under this level. Maybe let's write all of them. We have Fortran, Formula Translator. Under the fourth generation languages, we stated that they are visualized, like we have Delphi, Pascal. We also have Visio Basic, and we have Visio COBOL, and many other. They are Visio programming languages. Fourth generation can also be referred as Visio programming languages. So these are structured programming languages, Visio programming languages. So fifth generation, we stated like we have Macule, Lisp. So these languages normally used for artificial intelligence, and some of these languages are normally used to generate codes. They are code generators. I also stated like we have other content management systems like WordPress and so on. So that is under fifth generation languages. Then object-oriented, we have languages like Java. We have languages like C++, languages like Python, Ruby, a number of languages that works under object-oriented approach. That is why a program is created by combining objects together. Under web scripting, we stated we have the HTML languages, we have the JavaScript languages, we have CSS and so on. So out of these languages, you are supposed to choose just two. So you are supposed to just answer two. And since you are told to identify examples, then to identify examples, you just need to identify two of these languages. So that's how you are supposed to answer the two questions relating to programming languages.